Essay 3.1 3D Geometry and Optimization. With this section of the curriculum, we have to discuss the concept of distance, midpoint, and the 3D geometry. So let's first start with the distance and midpoint concept, and I'm going to call it section A, distance and midpoint. So before discussing the distance formula and midpoint formula in terms of this three-dimensional coordinate geometry, let's discuss about the distance formula itself first. Okay, so the distance formula is used to find the distance between 2 points in the like, coordinate plane. So in terms of 2D coordinate plane or 3D coordinate plane. However, with this example, we will be using the two-dimensional coordinate plane. So here I have point A and point B. Okay, so we want to calculate the distance between these 2 points, right? Point A and point B, and we could see the line drawn between these two points, which is the red colored line, and is the hypotenuse of a right triangle. So we know that this red line is hypotenuse of a right triangle. And the legs of this triangle would be parallel to the axis, which means we can identify the legs of this triangle, right? First, let's try to identify the legs. And these legs of this triangle would be parallel to the axis, and which means that we can measure the length of the legs very easily. Means, since we know that point A has the coordinates of the x1 and y1, we know that this point on x-axis is x1, and this point on y-axis is y1. And because we know that the coordinate of the point B is x2 and y2, we know that this point here is your x2 and this point here is your y2. Then using these points, we can easily measure the length of this leg here as y2 minus y1 and the length of this leg as x2 minus x1. Okay, then we can say the length of the distance is hypotenuse of the right triangle, right? So let's identify this as a length of the distance between points A and point B. Identify it again with the symbol D. Okay, then we can find the length of the distance D by using the Pythagorean theorem. So we know that the Pythagorean theorem has a formula of the a squared plus b squared plus equals c squared, right? So using this Pythagorean theorem identity, and we know that this Pythagorean theorem has this formula, which means it also uses a right-angled triangle, right? So we can say that when you have a right triangle, this is your C value, this is your A value and B value, right? The same thing can apply to this example here. We can say that the distance between the point A and point B, which equals to D, is equals to, so D squared is equal to x2 minus x1 squared plus y2 minus y1 squared. And from this step, we can identify the distance value as D value is equal to square root x2 minus x1 squared plus y2 minus y1 squared. And also, uh, the point that is at the same distance from the point A and point B on a line is called midpoint. So let's go back to the equation. So the point that at the same distance from the point A and point B will be like this point here, and this point is actually called the midpoint. Okay, and the midpoint has a symbol of the M, and we can use the formula x1 plus x2 divided by 2, y1 plus y2 divided by 2 to calculate it. Then similar concept or same concept applies to the three-dimensional coordinate geometry. So we specify an origin O and three mutually perpendicular axes called the x-axis, y-axis, and z-axis, right? So this means when you have a plane like this, we can identify it as z, x, and y. And if there are 2 points, such as point A and point B, we can identify the distance from point A to point B using the distance formula that we just developed. But in this case, we just have extra stuff, which is the z portion, the value of the z there. And also we can calculate the midpoint of this line using the exactly same formula, but again, with this case, we have the extra part, which is the values of the z-axis. However, these formulas are included in your formula booklet in the form of the two-dimensional coordinate system. Okay, then let's go over the example. So example number 1, a square base pyramid has base coordinates as follows, and the apex of the pyramid is given. So question A, we need to verify that the apex lies directly above the center of the base. So we need to identify the center of the base, right? So to find the center of the base, we locate the midpoint of the diagonals of this line AC and the origin and point B, and the midpoint of the line OB is also center of the base, and also the midpoint of the line AC is also the center of the base. So let's identify this line first. So line A to C, right? And also line origin to the B. Okay. So question A, the midpoint of line OB is same as this using the distance formula, right? And these values are equal to 3, 3, 0. And the midpoint of the line AC is same as this, and it gets simplified into 3, 3, 0. And you can see that since the center of the base is 3, 3, 0, and the apex point is 3, 3, 9, we can see that it is directly, the apex point lies directly above the center of the base. Yeah. Question BI. Suppose M is the midpoint of the BC. So we are referring to this point here. So this is the midpoint. We need to find the coordinate of the M. So Again, we use the midpoint formula. So we know that the midpoint M is equals to 6 plus 0 divided by 2, 6 plus 6 divided by 2, 0 plus 0 divided by 2. So this is equal to 3 comma 6 comma and 0. Okay, and now we need to find the exact length of the MD. So MD, the line MD is from the D points to here. Okay, so we know that the point M has the coordinate of 3 comma 6 comma 0. So we're going to find the length between the point D and point M. So BII, the length or the distance of the line MD is same as square root 3 minus 3 square plus 3 minus 6 square plus and 9 minus 0 square, right? Then we get square root 90. So this is equal to 3 square root 10. Okay, and we have to leave the answer in this radical format because the question says we need to find the exact length of the line MD. So we don't change this to decimal numbers.